Yok estağfurullah. Ben kayıt başlattım hocam. Merhaba arkadaşlar. Mikrolab dersine hoş geldiniz. Abbas hocamla beraber bu derste şey yapacağız. Anlatım yani Abbas hoca yapacak. Abbas hocamız yapacak. Ben de takip edeceğim. Gerekli olan yerlerde yine sorularınız olursa Abbas hocamla beraber cevap vermeye çalışacağız. Hocam buyurun.
Teşekkür ederiz hocam. Muharrem hocam sizden ricam bir de mikrofonu kapatabilir misiniz?
Efendim hocam? Tamam.
Mikrofonu.
Tamam hocam. Kapattım.
Teşekkür ederim hocam, kapandı şu an. Evet arkadaşlar, 24 kişiye ulaştık. Baştan şu uyarıyı yapayım arkadaşlar. Ders sırasında anlattığım konuyla ilgili sorusu olan olursa lütfen mikrofonunu açıp hocam bir sorun var, anlamadım şeklinde araya girsin. Çünkü bunu aşağı indirince yazdığınız mesajları görmüyorum. Bu konuda bir hemfikir olalım. Sorularınız olabilir. Lütfen beni kesin, araya girin, sorun. Dersin sonunu beklemeyin. Sıcağı sıcağına cevaplamam daha kolay olabilir. Okay, my friends. Today's topics are loops and increment and decrement. Decrement and increment is very easy. It's just increase a registry or memory, decrease the registry or memory. But the crucial topic of this week is loop. In 8086 architecture, we can create loops. Remember, in C, we have for loops, while loops, do while loops. In microprocessor, in this lesson, we have only loop keyword. But there are various ways to create a loop, but this is the original way of creating a loop. Okay, let's open the emulator first with empty workspace, and whenever there is a new lesson, remember we open the 8086 instruction set and go to that keyword. The first keyword in here is loop. But let me go over the increment and decrement first because they are very easy. For example, increment, where is inc? Okay, increment, it just gets one parameter. This is important. Do not use two parameters in here. It just gets one parameter. It adds one into that registry. For example, move AL3, increment AL, increment AL. You can write multiple times. These are different instructions. Return. When we emulate it here, we move 3 to 3 decimal to AL. Hexadecimal is also same. And we say increment AL. It will increase the AL by 1. And again, 1, 1. As you can see, AL is increasing. Another way of usage is memory usage. For example, let's use 1000H, and we want to increment the value stored in 1000. Let me copy this one. Okay. We move 3 into 1000 address. We put 1000 in here and go to that address. 2000 address is physical address with the value in 3. And in this instruction, we are going to increment the 1000H address, which is 2000 physical address, by 1. Okay, we run that code and go and look at the value. As you can see, that memory location increased by 1 again and again. And when I go over and look at that, it's 6. These are same things. And there are some flags affected. Only carry flag is not affected. It's unchanged. We are going to cover the flex in later weeks, so don't worry about this table. Simple example, algorithm is operand equals to operand plus 1. It just increments by 1. In C, remember, variable plus plus is same with increment. Okay, now go over and look at the decrease, azaltma, decrease operand. It's exactly the same, registry or memory. Operand is this time is subtract. Flex are same. Let's go over and, for example, I'm going to change this into AL again. I'm going to update increment to decrement. 3, incremented by 1, 4, decremented by 1, 3, decremented by 1 again, 2. The final state of AL is 2. This can also be again done with memory. I'm not going to go over it. But the crucial point is increment and decrement gets only one parameter. You can't do this. Increment AL by 3. This is wrong. Decrement AL with BL. These are all wrong. Okay? So increment and decrement is covered. There's only 2 of them. Go over and look at the loop function, loop keyword. There are different loop keywords. These are all creating a loop. For example, loop equal, loop not. Let me zoom in. Let me show that. Loop equal, loop not equal, loop not 0, loop 0. There are some other keywords. But first, let's learn the loop one, the simple one. Okay, there is loop, loop is here. Loop takes one parameter, which is label. What is label? Label is just a string. For example, the previous example, we move AL3. After the first line, I'm going to create a label named Abbas. After the label, you have to put semicolon and other operations and return. When we emulate this code, as you can see, emulated code is here. There is no Abbas in here. Did you catch that? You just put a mark in your program flow that you know. Okay. So label is just something you can create. Label 1, etc. Anything can be labeled starting with a alphanumerical character. Okay, so now go over and look at the loop again. It takes one parameter with label. So I'm going to go over and use loop keyword with the keyword with the label I created. Let me tap these 2 lines. Semicolon. Think about these labels like these curly brackets. Okay, the starting point of loop is here, the ending point of loop is here. So let's go over and look at the emulator. What it is saying, this loop keyword decrease the CX. Jump to label if CX not 0. What it means is don't complicate your minds. It just use CX, which is counter register. Let's move some value into counter register, like 4 decimal. Okay. and run this code. Okay, I run this code, put 3 in AL, as you can see, move 4 in CX. CX is now 4. I'm going to stack backward and step forward. Look at the right side of the codes. Anything labeled part is not instructed. You can see the yellow bar never touched anything. Okay, it's just a keyword staying there. Okay, we go over and run the increment AL. AL becomes 4, increment AL, AL becomes 5. Now we are in the loop instruction. What we are going to do, it checks the CX. Let's go over and look at the CX. If CX is 0 or not, it is not 0, it is 4. So it is going to jump to anything keyword. It jumps into anything keyword, but remember, anything keyword is not highlighted with yellow. It goes to next instruction. So it jumps into increment AL. Incremented 6, 7, jumps into increment AL, jumps into increment AL until CX becomes 0. But we didn't change the CX in anywhere in this code. We just put 4 in there and keep up looking at the CX value. CX is updated with loop keyword. Whenever a loop keyword comes, let me show it again. Whenever a loop keyword comes, CX decrease by 1 automatically. It just decreases CX itself. I reload this example, put 3 in AL, put 4 in CX. CX is 4. Please look at the CX in here. It becomes 3. Did you catch that? CX is decreased by loop keyword. If CX is not 0, jump to label. That's it. By this way, you can create a loops. For example, let me add some other codes. Like we already covered the add instruction. Add AL to AL with CX is 5. And let me emulate this with a delay. I'm going to run this code. As you can see, it creates a loop. At the end of this program, AL becomes DC. I don't know what it is. That we put 3, 4, 5. 5 plus 5 is 10. 11, 12, 12 plus 12 is 24. Goes like that. So this is loop. The students keep doing some errors. The first and the major error is doing this upside down. This is wrong usage. If you create a loop like this, when the instruction comes to loop keyword, it goes and look at the CX. If CX is not 0, it's going to jump to anything. So let's look at this example. 3, 5, CX is not 0, so it's going to jump to anything. It jumps to anything, and after anything there isn't any instruction and becomes return. The program is finished. So the between part never instructed, never run. Okay, this is the wrong usage of loop. This is kind of a code, but it's not a loop. So be careful. Keyword is label is first, loop is after. Okay, and you have to put semicolon at the end of this. If there is an space between this, emulative no, it doesn't affect. If you didn't put semicolon in there, Emulator gives errors. You have to put semicolon. There isn't semicolon at the keyword part. It's is it working this way? Yeah, it's working this way. But emulator, I think, corrected itself. Yeah. Let's emulate this one and see the right part of this. Let me show the codes also. Okay, this is move AL 3, move CX 5, increment AL, add AL, and loop. There's an address in here, 058. This is instruction address, the fifth instruction, or the value instruction pointer will be updated. For example, when we came here, keep look at the instruction pointer. Okay, incremented, goes in here. Instruction pointer will be updated to 5, so that it will goes in here. Did you catch that? Instruction pointer is 5. The value we jump. Okay, these labels are just storing the instruction pointer. Okay, that's it. This is loop. You can use loops anywhere. We are going to use them in multiple ways. Important part is you have to use CX. For example, if you use CH, for example, what will be the CX value? Who can tell me what will be the CX value? Is there anyone who wants to say what will be the CX value? When I put 5D in CH, upper bound of CX, what will be the CX value?
Sayıyı mı arttıracak hocam?
Tabii buyurun lütfen.
Sayıyı mı arttıracak? CX azaltıyordu. CH arttıracak mı?
Yok, hayır. Artma yok. We put some value into CH. I'm saying then what will be the value of CX?
Hocam 8 bitlik hale mi çevirecek kendisi? 16'lıktan 8'e mi çekecek?
Hayır. Neden 8'e çevirsin?
Çünkü CH kullanıyoruz ya.
Bu 16 bit. Bu 8 bit, bu 16 bit diye.
Hı.
Hayır. Let me explain this part in Turkish a little fast. Ne demiştik arkadaşlar? CH ve CL 8 bitlik değişkenler. Bunların birleştirilmiş hali CX'i oluşturuyor demiştik. Birleştirilmiş, yan yana konup birleştirilmiş hali, toplanmış hali değil. CH'ye ben 5 değerini koyarsam, hatta bunu H yazayım kafanız karışmasın, bir farkı yok şu an. CH'ye 5 değerini koyarsam oraya 0,5 yazar. CL'de şu an ne var? 0,0. CX ne olur? 0,500 H olur. Onları birleştirip 16 bitlik register'a çevirmesi gerekiyor ya. 8 bit, 8 bit. Anlaşıldı mı burası? Benim kameramda bir sorun var ama. Bayağı geç geliyormuş. Onu bir düzeltmeye müsaade edin bana. Niye öyle gecikmiş anlamadım. Yok. Kameram bugün iyi değil. O yüzden kameramı kapatıyorum. Boşuna sizin ekranınızı şey yapmayayım. When we put 5 in CH, let's emulate this code and see it there. Let me comment out these parts. When we emulate this code, you can clearly see what will be the value in CX. AL is 3, CH is 5. Did you see that CH is 5? So what is the CX? It is 500 H. The combined value is CX. You can use separately those 8-bit registers, but CX is 16-bit registers, which will be concatenation of the CH and CL. Okay, so I put 5 into CH, and I'm going to emulate this value. As you can see, it keeps going. Let me faster this one. I just put 5 in CH. Well, it's keep going and going because loop keyword looks for the CX, the 16-bit register. And CX is, as you can see, decreasing by 1 in here, 3, 500H. I don't know the decimal part of it. It will be run like that. By the way, as you can see, AL is overflowed already. FC, FE goes like that. So be careful. When you are going to create a loop, it checks the CX. Either you put CH or CL. For example, I can use CL. This will be the same with using CX because the number is just 5. 5, 4, 3, 2, 1, and it's finished. The AL is DC. So this is also another crucial part. Okay, let's go over and look at the example. If there is any question, interrupt me now. Write a program that calculates the sum of the numbers from 1 to 100 and saves to the memory address, save result to the memory address 1000 hash H. It's just a program summing the numbers starting from 1 to 100. We need to write a program. Let's write it. Let me put it like this. I'm going to open this with PDF. Okay, let's clear this out. The question is here, write a program that calculates sum of the numbers. Sum of the numbers between 1 to 100. What we are going to do, we need to create a loop. As you can see, from 1 to 100, we need to create a loop. Let's write a label like my name and loop keyword with that label. We are going to do some operations between these two blocks. Okay, what is the operation? We are going to add some value into, for example, AX, and we keep storing the value into some register, for example, AX. I'm going to put the values into AX. And let's write return at the end. At the beginning, I should have changed the data segment. For example, move BX 100H, move data segment BX. This is just changing the data segment to 100. We are trying to make sure that it is 100. Okay. So how many times this loop needs to run? Who is going to say that? How many times these loops needs to run? We are trying to find the sum of the number between 1 and 100. Ömer says 100. Any other answer? 0. 0? these loops need to run at some times. I know, I'm asking what will be the CX. How many times does this loop needs to run? Okay, Ömer is right. These loops needs to run 199. Sorum arkadaşlar, 1 ile 100 arasındaki sayıların toplamı için döngü ne kadar dönmeli? Kaç kere dönmeli? How many times these loops needs to run in order to calculate the summation of these numbers? So these loops needs to run 100 times. So I put 100 into where? CX, right? Because loops looking at the CX. We put 100 decimal into CX or 64 hexadecimal into CX. These are the same things. So this is a loop. And let's emulate this code. Make sure that data segment is 100. Yes, it's 100. Let me see the question again. The result will be 1000. Okay, no, we didn't find the result yet. CX is 100 decimal. As you can see, it's 64 hexadecimal. Now we are in the loop. Loop has only one instruction, which is adding 1 to AX. Adding 1, adding 1, adding 1. What will be the result? Let's see. Result will be 100. So this is not the correct loop. What we are going to do? We need to add every digit between these numbers. For example, 2, 3, 4, goes like that. We need to add every one of them. That's why let me create another variable and use another variable, which is dx, and put 1 in it. And I'm going to add another variable dx, which is d1 in now, and after that increase dx. Okay, and I emulate this code. Data segment is set, cx is 100, dx is 1. Now I'm going to add them into ax. Ax is 1, dx is increased, dx is 2. Now 1 plus 2 is 3. Dx is now 3. 3 plus 3 is 6. It goes like that. And the result will be 13th BA. So let me calculate the 13th BA. Hexadecimal 13th BA, which is 5050. Okay. This is the correct usage. We just use lots of variables. bx for data segment, cx for counter, dx for the number increasing, and ax for the result. We used all A, B, C, D. Let's change this and make this code more, let's not say memory efficient. Yeah, more memory efficient. Okay, we have already CX. CX is also register. I can use CX in here. Delete this line. What this code will do, it will add CX into AX, and the loop will decrease the CX and add into AX. For example, let me update this code this way. What we have just done, we have increased the dx, but now I'm going to decrease the dx and add the numbers starting from 100. 100 plus 99 plus 98 plus 97 goes like that. So this is exactly the same, right? As you can see, the result is 13 BA. So I try to get rid of this dx because cx and dx is same. Dx is decreased by me, but cx is decreased by loop. So get rid of this dx and use cx instead, which will be more memory efficient. A single line calculating the summation of 100 numbers, which will be 13 BA. Cx is now 0, dx is 0. We only use bx for data segment, which is default value is already 100, so get rid of them also. With 2 memory, we just cover the result, and I'm going to use directly memory location, adding cx into memory location, and I'm going to emulate this one. Okay, and let's go over and look at the 1000H address. As you can see, the result is 13 BA. So I use only single register, but at the beginning I was using 4 registers. Okay. Any question? Hayır, aynı sonucu almazsın. Increment'i add'den önceye koyarsan 0 ataman, önce increment yapman lazım. Biz 1 atadık, sonra increment yaptık. Yani ilk atamayı önemli. İlk atamaya ne koyacağın önemli belki. Evet Mehmet. Biz de onu yaptık. Görmedim yazdığını. Çok güzel soru Utku. Müthiş soru. Evet. I forgot to mention that CX is already registered and we can manipulate CX within the loop. For example, I'm going to decrease CX by myself also. For example, we add CX into 1000H. I'm going to decrease CX. CX becomes 63, and loop also decrease the CX, which become 62. So this is double time decreasing. What will be the C variant of this? For example, in C, you create a loop like this, int I equal to 0, I is smaller than 10, I plus plus. When you write it like this, this is just using loop keyword, which will, let me write it the correct way, which was CX is starting from 100, E is greater than 0, E minus minus. But what did I have? I just decrease CX by myself. And I update this for loop with like this. We just create a loop like this. This loop will run 50 times. Okay? Yeah, Mehmet. This can be a exam question, by the way. How to find the odd numbers. How to add the odd numbers. What will be the odd numbers or even numbers? Okay. So yes, we can alter CX within the loop. But be careful because you have planned your CX value before creating a loop. If you update CX or use CX as a, for example, let me change this code into something like this. you just put the parameter in the wrong place, let's say. We plan to use AX and increment the AX like this. Only parameters are wrong, as you can see. When you emulate this code keeps updating CX. CX is increasing, as you can see. It adding value, so it's not going to run 100 times, and the result will be not in AX. When this is going to stop? This is going to stop when the overflow becomes. So there is no overflow, it just goes over to next. So this is endless loop. Oh, by the way, you can't create intentionally create an endless loop with loop keyword. We are going to create endless loop within the next weeks with jumps. For example, jump. Just forget about it. This is endless loop. Keyword, jump to keyword. Keyword, jump to keyword. This is endless loop. For example, let me put a delay, something like this. This is endless loop adding AX into CX. It will not finish because there's no ending condition. Okay, another question. So there isn't any question. Let's go over and look at the second question. Write a program that reads value from 100th age between 1010 200 age memory range and writes back to 1000 age and 1010 200 age. As you can see, these are the same location. Memory range is same, but the segments are different. So we are going to use the twins, the data segment source index twin and exit segment destination index twin. Let's start writing this code. We are going to get value from here to here, but we need to add 1 to every word. Okay, so we need a loop again. How many times this loop needs to run? What is the range of this loop? This is critical. Mehmet says 200 age. Any other? Any other answer? No other answer. Both of them is wrong, by the way. 200 age, no. Arkadaşlar şöyle bir şey parmak basayım, Türkçe hızlıca anlatayım. O 200'dü, 201'di, 199'du, onlara takılmam. O yüzden yanlış söylüyorsunuz derken onu kastetmiyorum. No, 201 is also wrong. The keyword, it is important part is in here is word. We are going to calculate every word. We get value, a word from here and add 1 and put it into here. A word from here, add 1 and put it into here. So the range 200 age, this is correct, but you have to use it word by word. Remember, every line in this memory is byte. Word by word means you have to calculate the half size. So the correct answer is the half size of, let me calculate that, half size of 200, which is 100 h. Correct value is 100 h. So we are going to put, let me close this, 100H or 255 into CX. Okay, the loop is going to be 100H. We need to copy from, get a value from, for example, let's write this value directly from 1000H, but the address should be 100, and add 1. Adding 1 is increment AX. Remember, you can also add AX1. This is also same. Okay, now I need to go and put it into 300 and 1000H. I'm going to put the value into 300 and 1000H. What is the value? Value is AX. So this is the steps I'm going to use. Get the value from 1000H, increment it by 1, put it into 1000H, but this time segment is 300. Please be aware that I'm getting 1000H value into AX. If I write a code like this, the emulator automatically gets the 1000 and 1001H into AX. Because AX is 16-bit, you just pointing the starting address of that location. The size is calculated with a parameter. Okay. By the way, this must be error. This shouldn't run like this. Oh, I forget the comma. Yeah, you can't directly use this semicolon usage. That's why we are going to use, as question stated, data segment and exa segment. Let's say 100 is data segment, 300 is exa segment. It doesn't have to be that way. You can vice versa too. We are going to use just 2 segments. I'm going to update using bx 100H into data segment. I'm going to update bx again and put 300H into exa segment. And get rid of this front part by writing data segment and exa segment. So this is correct now. We put 100 into data segment, 300 into exa segment. Exa segment is 300, data segment is 100. Okay, but we put 100H into CX. CX is now 100H, as you can see. The loop is running. It keeps getting the value of 1000H and put it into 1000H. Let's go over and look at the 1000H of 300. As you can see, it becomes 1. Why? Because 1000H has value of 0 in it. Increased by 1, it becomes 1. But there is no other value going to change. So we need to change the loop. These loops keeps updating the same location. But we need to update the memory range between these 2 addresses. Okay. So we need to index. Remember, in emulator we have indexes, source index and destination index. And question also saying that you need to use data segment source index twins and exa segment destination index twins. So I'm going to put destination index here and source index here. But before that, I need to put value in source index 1000H. So destination index 1000H. Remember, they are pointing the same location, starting from 1000H. Is this enough? Let's emulate and see the code. We put exa segment in this data segment, updated that. We put source index 1000H, as you can see it's 1000. Destination index 1000H, yep. Put 100 into CX, yes. And gather the 100 and 1000H into AX. AX becomes 0. It's already 0 because 1000H address doesn't have any value in it. It's 0, so it gathers 0. We increment AX by 1, and we put this value into exa segment destination index, which is 300. And what is the destination index? Destination index is 1000. When we go over and look at that, the 4000 and 4001 becomes 0001. So this is correct. But when I run this code, it's again using the same location. It keeps updating the 4000 location. It's not going to update 4002, 4004, and 4006. So I need to increase these both instructions at the end of this loop by using increase twice. We are working word by word, or adding 2 into this instruction. So this is the correct usage. Two-way, you can increase or just add 2. When I run this code, okay, let's wait a little bit so that it can update some value. Stop. Okay, now I'm going to exa segment destination index part. And as you can see, word by word, all of the words have increased by 1. The least important byte will be written into first, and the most important byte will be written later. So this is the word 4000 and 4001. How we are stating? We are stating by using AX. For example, if I use AL in here, it just copied the byte, not word. So I used AX so that it copies the word from data segment source index. So these are same location. Let's just use a single index and use, for example, data index. Is it work this way? I think it's work. Yeah. It's not correct actually, but you can also use a single index in parentheses so that I just update the data index, destination index, sorry. Okay, so the question is this. Let me show it like this, be more official. We gather value, a word value, gather word from data segment source index, and by 1, restore word into exa segment destination index. The above part is updating data segment and exa segment. Because questions say that you should use those values. You don't have to use exa segment. For example, let's use data segment only. But you have to update within the loop every time you use those values. So I'm going to put some value into bx like 300h, move some value into, for example, dx, and 100h. At the beginning, I'm going to update data segment as dx. I'm going to erase these ones. Remember, if you don't show anything before these parentheses, it's going to use data segment. Before this, I'm going to update data segment again with what? bx. bx, dx, bx, dx. It keeps updating the segments within the codes. This is also correct, but not a memory efficient or instruction efficient way. So let's go over and look at the 300. As you can see, by just using a data segment and keep updating it, we create the loop again, but it becomes bigger. The code increased. So it's up to you. But remember, if you didn't intentionally say it is data segment, it just put itself. If you are going to use exa segment, please use exa segment beforehand. Okay, so any question? Any question? You can't just directly understand all of these codes. There must be some students. The last part, the data segment part. Ömer, do you mean the data segment usage? Do you mean data segment usage? Let me stop recording this lesson in here, and I'm going to explain after the record, because in record they can go back and look at the parts. Muharrem hocam,
Hello friends. Merhaba Abbas hocam.
Hocam dersimizi tamamladım. Bir arkadaşımın sorusu var. Kaydı durdurursanız hocam.
Okay, is there any question for me? No, okay. Hocam ben kaydı kapatıyorum şimdi.
Teşekkür ederiz hocam.
Teşekkür ederim.